While learning more about debugging in Godot, I realized that there are several very good videos on how to set up debugging for Visual Studio Code. But unfortunately, most of them end when it gets interesting. Modern IDEs offer more than just setting breakpoints. Today, I'll show you how to use the debug tools in Visual Studio Code and two nice features of Godot to debug your game. My name is Julian, and without further ado, let's start into the tutorial. I briefly show you my setup, but if you want to dive right into the debugging part, just skip to the next chapter. If you use Visual Studio Code, a VS Code directory is usually created. To run your game via the IDE, it must contain a launch JSON and a tasks JSON. The launch file contains configurations to run the game or a scene in debug mode. The debug scene configuration is quite handy if you only want to debug a specific scene without changing the default scene. The downside is you have to change the name of the scene you want to run. The last entry will attach the debugger to a running process, so you can simply start a scene from the editor. However, you must find the right process, and you will miss the breakpoint within the ready method because the scene is already initialized. The tasks file contains the build configuration to compile your code. You can copy the configuration from the Godot documentation, which also provides further explanation. I'll put the link in the description. Let's say your codebase has grown. Some errors are no longer as simple as they were in the beginning, and you observe an unexpected behavior or an error. But the code should actually work. This is where the debugger comes into play. My little code example here is far away from that, but it will help to explain the features. As you may notice, it increases a variable called count after a period of time or by pressing space, and it prints the current value to the console. Our bug is that the code within the if condition in the process method is never reached. Let's switch to the debug view to add a breakpoint, so we can see what happens and what the editor can tell us. By the way, you can add and remove breakpoints at any time. As expected, line 20 is never triggered. So let's add another breakpoint at line 17, which is triggered in any case. In the variables panel, you can see the value of each variable within the scope of the breakpoint, so only this and delta are listed. If we extend this, we will also find weighted, because it is a class field. Since we inherit from node 3D, there are a lot of other class fields. Press continue to skip to the next execution of process. We can see that weighted increases as expected. Now we can either watch the value or let the IDE do it for us. Since a Boolean expression is required, I will check when weighted is greater than 2 and when it is equal to wait time. Then I restart the run because weighted is already greater 2. We are now able to monitor the changes, and as you see, weighted is greater than 2 but not equal to wait time. And if we hover over weighted, we see that the difference is very small. We could repeat the run several times, but the chance that weighted is exactly 2 is rather low. So let's rewrite the condition to check if weighted is greater and restart the run so that the changes can take effect. I remove the first breakpoint so that we don't need to continue till the condition will match. Looks like it works. Next we take a look at the call stack, which can be thought of as a chain that lists all calls down to the method that contains a breakpoint. If we set a breakpoint in line 40, we can see from where the method was called. Before starting the run, I increase the wait time so that we have more time to use the key input. As you can see, the call comes from process, but when we proceed and press space, we can see that the call now comes from input. This information is extremely helpful if only one specific call is responsible for an error. If we now press step out, we jump directly to the point from which the method was called. Sometimes this function can be a little confusing because if you not press step into, the cursor doesn't jump back, but goes to the next method, actually like step over. If you not press step into, again for print count, it works as expected. In general, however, they are quite helpful. As next, let's take a look at how to change the behavior of a breakpoint. Let's go back to the process method and interrupt only when weighted is greater than 2. Set a breakpoint, choose an expression that evaluates to true and press enter. Run debug and see what happens. By the way, you don't need to use the variable at the breakpoint, you could also use any other variable in the class. If you just want to log something, use log message. Write a variable into curly brackets if you want to print its value. Sure, you could also simply add a gdprint, but the advantage of the breakpoint is that you can combine conditions, and you don't have to clean up your code. Hit count helps when debugging loops. So if we add a breakpoint in line 32 and set hit count to 4, the breakpoint is triggered on the 4th call. This also works with while loops because only the number of calls is evaluated. Wait for breakpoint lets you wait for a specific breakpoint. For example, let's wait an increase count by for the breakpoint in input. Now, even while the method is called in process, the breakpoint is not triggered, but only when I press space. Another very helpful feature is the code execution in the debug console. So if a breakpoint gets triggered, you can execute any expression within the scope of the breakpoint. By the way, if you don't know what scope stands for, loosely speaking, it's the access area of a method or class. So you can't access the local variable of another method, for example. Let's try it out. If I init increase count by 6 and then count, you can see that count has been increased to 6. If I now continue, my change is kept. This is very helpful if you want to quickly test the output of a method or how your code behaves when you need to play around with the values. For the last part, let's go back to Godot. If you've worked with Unity before, you probably miss the ability to see what's actually happening while your scene is running. To be honest, there's nothing directly comparable, but the remote view and the camera override are very useful features. In this example, I have a script that should copy the box 2 times and attach them to the node called spawn target. To check that the boxes are not simply placed on the root level, we can run the scene and then switch to remote. Now we can look at the tree and see if the boxes are where they should be. But it gets even better. If your game is running and you want to check something far away from your camera view, maybe because your camera is fixed, then you should click on the little camera icon here, which is called Project Camera Override. Then you're able to navigate through your scene with the editor view. I hope you enjoyed the tutorial and learned something new. Write me a comment if you have any suggestions for improvements. Till then, thanks for watching.